So we're going to start our conversation about graphing lines, talking about horizontal and vertical lines, and the easiest way to remember that. So horizontal lines have a zero slope and are a y equals equation. Vertical lines have an undefined slope and their x equal equation. The easiest way that I have found to remember this is VUX. So H-O-Y, and then VUX is going to be V-U-X, V-U-X. And this is an acronym to help you, so which means those letters stand for something. But if you remember VUX, that means H stands for horizontal. So we know that's a horizontal line. And horizontal line means it's going from left to right, which is why we wrote it this way. It's going to have a zero slope. And it's going to be a y equals equation. So y equals a number. VUX is going to be vertical, which is up and down, which is why we wrote VUX up and down. Undefined slope. And then it's going to be an x equals a number equation as well. And it's as simple as that. So if you can remember that horizontal has zero slope, it's a y equals equation. So when I say y equals, not y equals mx plus b, just y equals and a number. Excuse me. So up here, we have an x equals -1. So if we think of Hoy and VUX, that's an x equals. So that means we know it's going to be a vertical line going up and down at -1. So I'm going to find my -1. And I know that this is x is -1. If I told you x is -1 and then said, can x be 2? Hopefully you're like, no, you said it was -1. So no matter what y value I use, x will always be -1. So that's how you get your vertical line in this case. It's going to go up and down because for every time, no matter what output, x is -1. So a vertical line going up and down, passing through the x-axis at -1. Same thing for y equals 5, but opposite. So that's your Hoy. So we know it's going to be horizontal, which means left to right. And this says y is 5. So y is 5. So I'm going to go to the y-axis and go to 5. When x is 1, y is going to be 5. When x is 2, y is going to be 5. When x is 3, y is going to be 5. And so on. And even when x is -1, y is going to be 5 because that says y is 5. And then you're going to draw a horizontal line straight through -5. So once you remember Hoy VUX, it's probably one of the easiest sets of lines to graph would be your horizontal and vertical lines. So number 3, y equals -4. So that's a y. So again, that's Hoy, which means it's going to be a horizontal line because it's a y equals equation with a zero slope. So I'm going to go down to -4. Y is -4 all the time, no matter when. And so we're going to draw a horizontal line passing through y equals -4. Then x equals a +4, which means we're going to go on our x-axis. Remember, x is left and right axis, and then your y is up and down. So x is 4, and that means x is 4, x is 4, x is 4, no matter what y value you use. Or again, if you remember VUX, if you have an x equals equation, it has an undefined slope, and it has a vertical line. And vertical, remember, is up and down. So vertical line, up and down, horizontal line, left and right. Now, with it being that easy, hopefully at this point, if we're looking at graphs, we can write these lines as well. Still keep it in mind, Hoy VUX. So H-O-Y, horizontal, zero slope, y equals, VUX, vertical, undefined, x equals. So if I see my line here, it's passing through 4 on the y-axis. So y equals 4. Because it's 4 here, and it's 4 here, here, and all the way through. No matter what x value you get, y is 4. Number 6 is a vertical line going up and down here, and it's passing through 3 on the x-axis, because remember, VUX, vertical line, means I know I have an x equals, and I just need to figure out what number that is. So x equals 3, because it's 3 here, 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 and here, all the way through. So if I were you, I would try pausing the video. Our line is here, and our line is here, and try number 7 and 8 on your own. If you mess up now, there's nothing's going to happen. So go for it and figure out where you get confused. So again, this is a vertical line. So VUX. So that means I'm having an x equals equation. So I need to figure out what value of x. It's over here at -5. All the way up and all the way down. So we know x is equal to -5. Number 8 It's a horizontal line because we see it's going this way and this way, which horizontal is hoy. So we know it's going to be a y equals equation. We just got to figure out what the value is of y. And in this case, it's crossing at the positive 2. So y equals 2. Now, in slope-intercept form, we know y equals mx plus b. This is a short little insert of y equals mx plus b. So we know the slope, which is our rise over run, or rate of change, and then our y-intercept. And y-intercept means your starting point on the y-axis. So y equals negative 2x plus 1. So if I think of mx plus b, my m, which is our slope, is negative 2. Remember, we always have an imaginary 1 underneath it. And my b value is a positive 1. So I'm going to go to positive 1 on my y-axis because that's y-intercept. And then I have a negative 2 over 1 slope, which means this line needs to be coming down to the right. So I'm going to go down 2 over to 1 to the right, down 2 to the right 1, or up 2 to the left 1, up 2 to the left 1. Make sure you know this is a negative 2, that this line is decreasing as I read from left to right. In this case, it is. I want to go all the way through our graph, and now we have our negative 2x plus 1. This is in standard form, which is not going to help you out much. We need to put this in y-intercept form, or slope-intercept form. So 5x minus 4y equals 16, and that means we need to solve for y. So we're going to solve for y. That's the variable we need to get by itself. We have our line of great divide. What's on that side with you is going to be that 5x that we have to move first, which is always the case for standard form. When it's in standard form, you're always going to move your x. It does not combine with 16 because they're not like terms. And then you're always going to get your y by itself. So divide by whatever's on the y. And we're keeping them separate to each term. So that way we have our slope and our y-intercept instead of a big messy fraction. So then our negative 4's go away. So y equals negative 16 divided by negative 4, which is going to be a negative 4. And then our slope, negative and negative, is going to be a positive 5 over 4x. So even though they're in the wrong necessarily seat, we know the coefficient of x, that 5 over 4, is your slope. So coefficient of x, whatever the number is attached to x, is your slope. And then our number, our constant is going to be where you start. So negative 4 on the y-axis always on the vertical axis of y. And then we're going to count up 5. 1, 2, 3, 4, 5. And over 4. 1, 2, 3, 4. Looks like that's probably all we're going to get. 1, 2, 3, 4, 5. 1, 2, 3. Yep, we're way over here. And we can't get any more here. So we're going to just draw that line through here. And if you're not able to draw a super straight line, use the edge of a piece of paper, a Post-it note, a ruler if you have one's even better, side of a notebook. But it is pretty important to make sure they're straight because that's going to matter at the end of the day when you start counting your slope or matching up graphs and things like that. So again, it's a positive slope, which means it's increasing to the right. In standard form, you have to get y by itself to be able to graph by plotting a y-intercept and counting out your slope. You can't find that in standard form. So you need to go from standard to slope-intercept form. Same as we did with our horizontal and vertical lines. So write the slope in y equals m, the slope-intercept form of this line. So slope-intercept form, all you need is slope, and that's counting the slope like we did before, and where it crosses the y-axis, the y-intercept. So if I'm looking at this, it touches the y-axis right here at negative 3. So that means my b value is going to be negative 3. I want to find another good coordinate, and it looks like there's one out here, and there's one out here. This line is decreasing as I read from left to right, so it is going down, so I know my slope is going to be negative. Looks like I went down 1, 1, 2, 3, 4, 5. So the rise is 1, and my run is 5. And you want to check it and make sure you get it twice. Down 1, 1, 2, 3, 4, 5. Down 1, 1, 2, 3, 4, 5. Yep. So rise is 1 over 5. So to write that as its equation, y equals m x plus b, but in this case it's a negative 3, so it's probably going to look like this. But if you wrote plus a negative 3, that would be fine as well. So both of those are great answers. Number 12, so you need to identify where it crosses the y-axis, which is going to be right here at 5. 1, 2, 3, 4, 5. Yep. So b equals 5. And then we need to find another good point. There's a good point. There's a good point. And when I say good point, like it's passing through an intersection on your coordinate plane. So you're standing on the corner downtown Southern Pines or downtown wherever they have lots of blocks. I just think of Southern Pines because they're like, you can see the squares in Southern Pines. So you're standing on the corner. So you need to make sure you're hitting a corner, a perfect intersection, not standing in a store's yard, but a perfect intersection. So in this case, it's a positive line, and it looks like it's rise 1, run 1, rise 1, run 1, and it's positive because it's increasing or going up when reading from left to right. So my M is going to be 1. You can put 1 over 1, but remember 1 over 1, we normally get rid of the 1 on the bottom because that's an assumed number for all whole numbers. So y equals 1x, and you'll probably see it without the 1 there because, again, the variable in front, the coefficient in front of x, if it's a 1, is usually assumed as well. And then plus 5. So y equals x plus 5. All right, guys, those last 4, super, super quick. If that was enough, jump in and start your delta or move on to your next thing. If not, I'll check you on part 2 for graphing equations.